Good day everyone. In this video, we are going to learn how to use matrix method to solve simultaneous linear equations. Normally, we solve this system by using the elimination or substitution method, but it is also possible to do it with a matrix operation. For example, solve the simultaneous linear equation by using the matrix method. Before we start setting up the matrices, it is important to do the following. Firstly, make sure that all of the equations are written in a similar manner, meaning that the variables x and y need to all be in the same order. Second, express the simultaneous linear equations as a matrix equation in the form Ax equals to b, where A is called the coefficient matrix, the coefficient of first equation 1 and 2, the coefficient of second equation 3 and 4. X is a variable matrix x and y, and B is the constant matrix 4 and 10. Make sure that one side of the equation is only variables and their coefficients, and the other side is just constant. Third, transpose the coefficient matrix from the left-hand side to the right-hand side. It becomes an inverse matrix and placed at the left-hand side of the constant matrix. Calculate the inverse matrix of A. Recall the formula of the inverse matrix. Let's say we have the matrix A with elements A, B, C, D. For inverse matrix A, swap the positions of A and D, put negatives in front of B and C, and divide everything by the determinant AD minus BC. This is a simple formula for the inverse matrix of 2 by 2 matrix. Now, try to find the inverse matrix of A. The variable matrix x and y equals to the determinant AD minus BC 1 times 4 minus 2 times 3. Swap the elements in the main diagonal 1 and 4 and put negatives in front of 2 and 3, minus 2 and minus 3, and the constant matrix. We have the determinant 4 minus 6 and calculate the product of the inverse of matrix A and matrix B. The first row, first column, 4 times 4 plus minus 2 times 10. And the second row, second column, minus 3 times 4 plus 1 times 10. We get the determinants minus 2 and a column matrix minus 4 and minus 2. Multiply the fraction with the column matrix 1 over minus 2 times minus 4 and 1 over minus 2 times minus 2. The solution to the simultaneous linear equation is x equals to 2 and y equals to 1. Once again, consider a pair of simultaneous equations in linear form. Firstly, make sure that all of the equations are written in a similar manner. From equation number 1, transpose 3y from the right-hand side to the left-hand side to become 2x minus 3y equals to 9. The variables x and y need to all be in the same order. Express the linear equations as a matrix equation in the form Ax equals to b, where A is called the coefficient matrix, x is the variable matrix, and b is the constant matrix. As we have seen from the previous example, the equation in the matrix form Ax equals to b can be solved by transpose the matrix A from the left-hand side to the right-hand side. It becomes an inverse matrix and placed at the left-hand side of the matrix B. Calculate the inverse matrix of A. The variable matrix x and y equals to the determinant AD minus BC 2 times 7 minus 3 times 1. Swap the position of 2 and 7. Put negatives in front of minus 3 and 1. Make it 3 and minus 1. and write down the constant matrix. We have the determinant 14 plus 3. Then solve the matrix equation by calculating the product of inverse matrix A and matrix B. The first row, first column, 7 times 9 plus 3 times minus 4. And the second row, second column, minus 1 times 9 plus 2 times minus 4. By calculating, we get the determinant 17 and a column matrix 51 and minus 17. Multiply the fraction with the column matrix 1 over 17 times 51 and 1 over 17 times minus 17. The solution to the simultaneous linear equation is x equals to 3 and y equals to minus 1. That's all for this video. Thanks and see you.